Hey, good morning, everybody. Sorry about that. Technical issues right at the moment I usually hit go. Um, Thanks for joining me. Good morning, or good evening, wherever you are in the world. Um, Part four of ship rising out of the water. Um, just going to keep working on this today. I've been working a little bit on it during the week, so I'll go over some of the things that I did. I've sort of changed a few things and had a few ideas for how to make it better. I wasn't super happy with where the water was at or where the foam sort of stuff was at in the flip sim, so I sort of played around with that a little bit and thought a little bit more about how to do certain things. So I hope you're all doing well. Thanks for joining me, and let's get stuck in. I am actually simulating at the moment, so I might just stop it. See if I can stop it there and turn on load from disk. Stop that from simulating. So this is the simulation that I currently have. It's a little bit hard to tell without the ship in there, but it's looking pretty cool. There's a lot of nice detail, a lot of nice collision detail, especially. So if you remember, I think previously what I had was sort of this. Let's see. Actually, I think I may have deleted it because of the size. Let's see. See if I have version 1. Nope, all gone. Okay, let's have a look at version 3. See if version 3 is there. I'd delete that one as well. Wow, I've been having a lot of space issues with these simulations. So version 4 was one that I wrote out during the week. And max the scale of the ship, it's roughly, I think, 20 meters or so. Let's have a look at the ship against the world scale. So we got 10 to 15, so 25 meters. Hey Manic, will you be doing Explosions Pyro series next? I don't know. Maybe I could. I certainly could. It's on my list of things to do. What would you like to explode? That's the question. I need some sort of context. So yeah, this was the sim I did during the week, and as you can see, it's very sort of active and splashy, but there's a lot of really nice details coming in. So one thing that I did to get more details out of this is, it's getting a little bit messy, but here's my scatter. I actually changed the way that I was doing this. So previously I was doing the scatter above the attribute transfer. Waiting for 5 weeks for explosions. We'll get there. What do you want to explode? You tell me. I'll think about it. So I was doing the scatter before the attribute transfer, but that wasn't giving me like a really nice dense amount of points. So what I ended up doing was scattering after, so transferring color, just the same, but then scattering after based on CD. And that gives me a nice kind of consistent density of points all the way along, and I can control that a little more. So rather than scattering like 1,000,000 points before, I can just scatter 2,000, and it gives me kind of a nice level of points. But still, that's a little bit sparse. So a nuclear explosion. Okay, cool. Yeah, we could look at something like that. So one thing I did to get more points down here after all the point velocities and stuff. Let me just turn off. I'll delete some of these things. What's this attribute angle doing? Setting velocity. I don't need this blast anymore either, so I was scattering before, doing the color, and then blasting the black points away, so I don't need to do that now. Get rid of that. Just clean this up a little bit. So point replicate is giving me 10 points per point. So we've got these amount of points, and then for every point, we've got 10 points sitting around it, and that will give me extra amount of points there. So, and you can, obviously control the scale of those like that. So, I think I had around 0.2, something like that. Then I'm just coloring those, and I am setting viscosity to 0 because I'm still doing that viscosity stuff that we were looking at. So you can see I've been trying a few different things here, but that's basically, hey Rizwan, that's basically all I've done in terms of the source. I just changed the way that I was scattering. Now, previously I wasn't bringing in the water as a collision. I was just doing a ground plane, and then we looked at doing the displacement. I kind of think that maybe wasn't giving me the best results in terms of collisions with the water surface, so I just brought in the water to try out. So what I've done is brought in the water surface, done an extrude volume to create a volume, and then I've cached that to disk because it's quite slow. And then I've set the velocity, so there is a trail here calculating velocity. Just after that, I've set the velocity down because I was finding it was a bit too active, I guess. When it hit the water, it was sort of getting thrown out a bit. So I turned that velocity down there, and I can play with that value. I had to do it after the cache, that's all. I can't go back to the trail because then it would mean I would have to recache the water geo. And then I'm doing a VDB, which again is quite slow, so that's 15 million voxels at that point. Is not too bad. No, this is the water surface, Rizwan. If you remember last week we were doing the ship rising, so this is the ocean surface. So VDB from the grid, and then again cache that to disk. Now that's a really slow operation, so you want to cache that to disk, so you're not having to do that every frame. It's just reading from disk, and then you can see it's still pretty slow reading from disk, and this is reading off a solid state drive. So yeah, it is a reasonably slow operation, but it does give a better result. So if we have a look at the simulation that I was just writing out, version 5, so the difference between version 5 and version 4 here is just resolution. So this is at particle separation of 0.025. Hey Michael, how's it going? 0.025. There's a lot of stuff leaking underneath the surface, which probably we could clean up. 0.025, and then this resolution of version 5 is just double that, so it's 0. What is that? Actually, maybe it's more. Let's check. Oh no, 0.025 particle separation and 0.05 particle separation for this latest one. So this one's a little bit less splashy, which is good, I guess. You know, the spaceship is not rising up very fast, so I don't want it to be kind of, you know, super active. You want it to be a little bit active, but what I was getting out of version 4 was just maybe a little bit too crazy. Like you get these really huge bits, these strings kind of shooting up in the air, which maybe is a little much. The reason that this occurs is, like, when you've got two collision objects, I've got the water as a collision object and I've got the ship as a collision object, and where that sort of intersection point is, it creates like a little bit of friction or some sort of force there, or something gets caught in the collisions in that space where they overlap and intersect, and it creates a force which shoots the particles out. So the way that I've gotten around this in the past is to actually make the two things the same collision. So taking my ship collision and merging it with my water collision so that it's the same volume, and then you don't get an overlap or an intersection, it's just one volume together, and that actually seems to work well to calm that down. I haven't done this in this case. In version 5, just changing the resolution seems to have fixed that problem. Hey Hadik, how's it going? I'm good, thank you. How are you? Thanks for joining me. Water over the ring of fire. I'm not sure what that means, Ruzan, sorry. Is that a place, Ring of Fire? I think so. Or are you talking about Lord of the Rings? I'm not sure. So yeah, you can see just even doing the lower res simulation has actually calmed that down, and we still got, you know, some nice detail. So let's have a look at what I did. I think this stuff maybe, let's see, what was I doing here? Oh, I was transferring UVs. So this is what I did to get the texture of the water surface back on. So I think, I can't remember if we looked at this last week or not, but basically I textured the points so that I could do the displacement stuff. I don't know where that is now. It's in here somewhere. Here it is, texture. Adding the displacement map to the point position. And what I realized was that I actually needed to transfer the UVs from the original kind of grid, the original water surface, so that's this one. I needed to transfer those UVs because the UVs that I was getting out of this UV texture, if I look at spacebar 5, kind of, it just resizes those to be a good UV, but it's not really in the same position as what the rest of the water is that we're sitting this ship on top of. So to get the correct UVs in the correct space, I'm actually transferring from this water grid to our points, and then we get the UVs in the correct space. So when we do the displacement, not that I need to do that now because I've used the correct collider, but if I was to do that again, I would get that displacement happening in the correct location at the correct scale, if that makes sense. But yeah, because I use this collision now, I don't need to worry about doing that displacement. It's good to know about, and it's a good trick to have up my sleeve. Now, I do have a render here that I did from last week, so let's have a look at that. And based on this is when I started making changes, so it's only half res, so it's a little bit blurry, and this, I don't know if this will play back for you guys super well. But it revealed a few problems, and a few kind of things that looked good, but things that definitely needed to change. So you'll see here the foam interaction over the surface looks a bit weird. So you can see the way it spreads out feels a bit weird, and that's because there's plenty of other strange things. We'll talk about those in a second. That's because what I was doing, if you remember back to the wave tutorials, if you've seen those, or the wave series that I did this technique of using a point cloud to create this interesting sort of foam pattern. Let me turn off that. So you can see, you know, before we have this type of effect, let me go further, see if I have any points further. I did kill the simulation. So based on the location of these points here, I'm doing this sort of point cloud lookup to create these effects of like rings. You see it almost looks like a Voronoi noise. And that's what we see in that render. You can see that pattern there. But the way it spreads out through it looks a bit weird. So I was kind of like, yeah, maybe I'll abandon that. And this is when I decided to go for the proper collision. Now the other thing that, you know, I thought isn't looking too good at the moment is the pyro. The pyro is very active and it's squirting out like, you know, it's an emission of steam or something from the ship. So that's definitely something that I want to change. I haven't changed that yet. And that would really just be a matter of turning off the velocities, you know, and maybe some of the shaping settings that I have, and just having it drag, you know, just be left behind by the ship. So we can have a look at that. The other thing that I sort of, you know, with regards to the flip is that it's a little bit too coarse and a little bit lacking in detail. Like you can see this big sheet of kind of points on the surface, and that just doesn't look very good. So that's why I ended up changing the sourcing to make it denser amount of points, and also just increasing the resolution by decreasing the particle separation. Making that a lot higher resolution gives me a lot nicer details. So I end up getting, yeah, I think I killed it around 190, let's see. A little bit more, there we go. I end up getting, yeah, a lot nicer details there. If we have a look at that on the ship as well, let's go out, see if we can see it. There we go. So you can see there's a lot of nice details happening there. We're getting those strands, and this is just from the flip sim. We're not looking at the flip streams as well now, we're just looking at the flip. So we've got a lot of nice detail coming from that, which is great. Looks like I've also got some stuff on here. Let's have a look. Oh, I might have left that point VOP on. Let's check it out. I did. So we'll turn that off. We don't need that point vault. We'll just get rid of that. All I'm doing here is just the color stuff. So this was just the to get that blue-white ramp coloration on there. That's what I was doing there. But I'm actually turning that off in here. I'm just setting it to white again for rendering. If you ever got the chance, it'd be interesting to see how you approach ship passing through atmosphere. Do you mean a spaceship or a sailing ship passing through atmosphere, like a burn up type, like a re-entry type effect? Is that what you mean, Alan? Give me some more details. But yeah, I'll add it to the list. So you can see the flip now is looking really quite nice. We've got a lot of detail out of that, and then we've got our flip streams on top of that, which again could probably benefit from more detail. And then we've got our particles as well, our particle streams, which are the really, really fine ones. If we turn all those on together, and then we've got all this other stuff as well. So we've got the mist, and the mist is the sort of pyro element. So if we have a look at that, this is the one that's going to be looking like squirting out. Either would definitely be interesting. Yeah, re-entry. Okay, yeah, cool. Yeah, we could look at that. We've got spaceships. We can do some more space stuff. Yeah, the way that I think of things like that, re-entry, things like that, I would try to avoid maybe pyro as much as possible, and just try to do it more in a more procedural way with textures and particles. But yeah, we could have a look at it. I think, some of the things that I've done here where I do my simulations on a static object and then do the transformation after would apply to something like that as well. Because you've got this ship sort of moving super fast through the atmosphere, it'd be much easier to simulate, set it all up on a static object, and then, apply that animation after the fact. Let me add it to the list. Spaceship re-entry, and I'll add nuclear explosion in there as well. All right, so let's have a look at the pyro. Let's check that out, and we'll run that simulation in the background while we start having a look at some rendering things. So here's our source that we created. And here's our point velocity, which has a lot of curl noise on it. So if we turn on the V marker, you can see that these velocities are just shooting, out. They're just squirting out crazy. So that's what's causing that rising effect, or that sort of, effect of them looking like they're getting kind of squirted out. It's kind of cool, but it's also not what I wanted, so I need to fix it. We could just turn this way down so that there's still some velocities, or we could just get rid of this and just see what happens with zero velocity. So let's have a look at zero velocities and see what that looks like. Turn this off. What is this flip solver? I don't know why I have the flip solver in there. I guess I duplicated it for the static objects. Get rid of that. Doesn't need to be there. There we go. Alright, let's have a look at this. So we've still got gravity in there, and I can't remember, I think we were doing negative buoyancy as well. Let's check it out. Do we have temperature? Oh no, we're not. So we're not doing any temperature. So there's no buoyancy calculation. So it's just gravity that's going to be pulling this stuff down now. So you can see it is doing that, and it's getting sort of dragged over the ship. So it's going to be a much more subtle effect now. It's going to not be everywhere and not being kind of squirted out everywhere, which is probably a good thing. So this one is one of those times when I'm doing it on a static, so the transformation is done afterwards. Hey Michael, what's the reason you're using the sparse solver? Oh, no good reason really. I tend not to use the sparse solver for a lot of things, but it is, you know, it's quite quick for certain things, and because this is a simple pyro sim, I don't really need to do too much kind of custom stuff to it. I'm just using the very basic version, and that's why I don't really like the sparse solver for things like, yeah, just for the fun of it. Why not? Well, it's a little bit faster. I guess that's probably why I chose it as well. I don't really love the sparse solver for a lot of things. Flames I find difficult to make look super realistic with the sparse solver. But I'm trying to use it, you know, more, because I'm sure this is the way that Houdini is going to go, you know, to use more of these sparse solving techniques, and, you know, eventually into the GPU kind of realm. So I'm trying to force myself to use the sparse solver a little bit, but I still don't love it for, you know, for a lot of things. The look is just different, and I find the resizing stuff is sometimes, you know, when you want to do some specific customized resizing, it doesn't really let you do that. So yeah. So now we've got no kind of emission velocity. It's very linear feeling. So what I might do is create a custom velocity here. Let's have a look. So we've got our points, we're raying them onto the surface of the ship. What I might do for the ship, let's see, we've got, do we have normals? Do have some normals. Let's take a look at those normals. So these normals are coming from the ship originally. So there's our ship. We've got some normals there. And then we're peeking off the surface of the ship using those normals. And then they get copied onto the point replicate as well. And then we ray those back onto the surface. So we could just use those normals as a bit of emission. And I think, I don't know if we are doing that. No, we're not. So we could just do that. That will just push it ever so slightly off the surface. So let's do V at V equals V at N. Like that. And there you go, you can see we've got velocity. So let's just have a bit of a look at that and see how that helps the emission. I just want it to sort of, I don't want it to squirt out, so I'll watch the amount of velocity that's being added there, but I do want it to sort of have a bit more, you know, interest than just being a completely linear effect. And perhaps we could add some more turbulence maybe. Or we could try and create a different vector as well that's not just straight out. We could try and create a vector that runs along the ship, perhaps. Let's take a look. There you go. So you can see a bit of directionality happening now. Maybe it's a little strong again. So let's just, you can see those two streams there kind of crossing over, which is a little bit weird. So I might just turn this velocity down. Let's go 0.5. So you can still see them crossing over a little bit, but it's definitely, you know, a little bit better. And I mean, we could have curl noise on there, just super subtle, just to create variation. But overall, I want to sort of stop that look of things really kind of squirting out. So let's have a look at the volume visualization here. It's a little hard to see. Let's crank up the density. Let's turn this off so you can see it a little clearer. So might need to run the sim a little bit longer. You can see overall it's got a lot more of that sort of downward direction to it. We'll run it a little longer and see. Hey Audrey, sorry, I'm not sure if I said hello. How are you going? Alright, I think that's gonna work better. Let's have a look, compare. Maybe? Hard to tell. Really need to. You're the one who was late. How rude. It's alright. I'm just gonna make this slightly lower resolution and then run this again. Let's see. How much space do I have? Yeah, this should be alright. V3. And I'm gonna save this to disk in background. Why is it doing that? I don't know. Okay, save to disk in background. Yes, it probably is the first time Audrey's been late. She's probably here before me most times. My weekend was good, thank you, Hardik. How was your weekend? What are you working on at the moment, Hardik? Alright, so you can see that's writing to disk in the background. So let's talk about rendering this stuff. So we've got a lot of different passes here, a lot of things going on. Sounds exciting. Alright, so what have we got? We've got our water. Let's check out our flip and see what frame we have up to. I think it's 190 something. 190. Well, let's go 180. 188. Yeah, there's a lot of stuff going on. Quite a few different particle simulations, pop streamers, pop mist, flip streams, mist pyro. I probably should split this out, into maybe a couple of streams, but when everything's feeding off the same source, it's sort of, it does make sense to sort of leave it all in the one, but it does become quite chaotic, that's for sure. And I could delete a lot of these sort of things that I've tried that didn't work or that I'm not using. But it's good to kind of leave them there just in case I want to use them again, or if I have another file that I go, oh, I was trying that in this file, let's go back and grab it. But if I delete it, then it's gone. Layer to the max, that's right. You got it. It's all about layers. So let's jump out and start having a look at this, these renders. So we've got some materials here set up. We've got the water and the ship, and I have created the foam and mist volumes. So I think we looked at that last week. And then I also have a pop streams one, which is just white, and I think it has a little bit of emission in it as well. Oh no, turn that off. Still working on destruction. Takes so much time. Solving problems. Yeah, look, these things, especially when you're learning, it takes a long time to solve problems. But even, even for me, it takes a long time to solve some problems. You have to learn and go and search for the answers. So let's take a look step by step. I'm going to just turn off particles, flip, turn off everything except for the ship and the water. I'm going to go out, and I think we have this one here, which just has a star, render star in candidate objects. So that should grab anything that's called render if it's got the view flag on. So let's have a look. Just us, Daniel, that's right. So we're rendering half res. We've got pixel samples of, I'm going to do 1 and 1. I've got motion blur turned on, that's alright. Yeah, I don't need to hit save because I've done that recently. Let's have a look. Surfacing test, camera 1, render. Always happy to answer questions. anyone has any problems as well, like sample files or things that they're struggling with, please feel free to ask. You don't have to be a CG Spectrum student to do that. If it's a simple thing, you know, I can take a look at it and give you some pointers or give you some ideas. I'm happy to do that stuff on the stream too if it helps. I have a file that I might open up in a little bit. Someone was having a problem with grains, and it might be interesting to talk about that. Alright, so there you go. You can see I made the ship black, because I thought that was kind of pretty cool. Let's have a look at the ship. So the ship is just metallic, reflective, and black with 0 roughness. So you can see if I crank the roughness, then it starts to kind of blur out. Well, that's super black. Let's set it to white, see what happens. There we go. It starts to go into that grey kind of space. So that's why I have the roughness down at 0, so it's just super shiny. So you can see there, you know, if I have it white, it sort of looks a bit like a chrome silver ship, which is also cool, but it would be very hard to see the water against that. So making it black will just make everything stand out. You can also, I think you can overcrank things like reflection. No, it doesn't really seem to make any difference. Let's try metallic. No, guess I'm wrong. Thought you could do that. Maybe you can with some things, not with this. You can also change the IOR, and that will change the way that the reflections look. Although, again, that doesn't really seem to be doing much. Maybe because it's metallic, the IOR might not be doing anything. Or this could be broken. Let's check that. I suspect maybe it's because of the metallic that the IOR isn't doing anything at the moment. But it should, in theory, change the kind of way that it reflects. Let's see. Let's see if it looks any different. Nope. Okay, so with metallic on, looks like that doesn't make any difference. Anyway, it's a black ship. It's reflective. You could make it like a, if you really wanted to, you could make it like a kind of, I guess we need a little bit of reflectivity, but you could make it like one of those super black, matte kind of cars, you know, that sort of super matte surface like that. Could be kind of cool as well. Let's take the value up a little bit. Alright, that might look cool. I don't know, I mean, you know, you just sort of play around with it to get the look that you want. Maybe a little less roughness might be good, just to get slightly bright highlights. You can also add a coat to these things as well, so you could have like that as your base reflection layer, and then add just a super reflective coat on top, which might look cool. That's kind of like your car paint shader, where, you know, the car paint sort of has like a metallic fleck look to it underneath, but then it has a super gloss reflective coat on top. So this allows you, using the coat and the reflectivity, they have different roughness settings, so you can kind of get that rough, flecked look underneath. So like, you know, by controlling this roughness, it allows me to set that up underneath, and then on top I can get my coat. Now maybe coat I can go more intense. Oh, there we go. So the coat, you can like crack the coat over one, and you get this super glossy sort of look. So that can be kind of a cool thing to do. That wasn't too bad. It's very noisy to render, so you can't really see the details, but there are a lot of details on the ship. Now, the water is just, it has the displacement texture on there, and I've just set the offset that I was playing with last week. Didn't seem to help, so I just set it to effect scale of 1. Surface is just this sort of bluey, slight green value in there, and then reflectivity 0.5. So it's not transparent at all. it's just reflective. So if I set the reflectivity to 0, you will see we just have a blue plane. So a lot of it is coming from the reflection. And we don't really need the, transparency. You could do it, but it takes a lot longer to render. So you can see reflectivity of 1 I find is too much. It feels a little bit too glossy. So I do find that it looks a little bit better when it's about half. I don't know, it doesn't look too bad here, but yeah, I just seem to prefer, I think it looks a little bit more realistic. I guess it dulls it down, it's not super bright, it just keeps a bit more of the colour in there as well. And yeah, adding a little bit more green to your ocean just gives it that kind of, a bit more of that sort of, I guess the more green you add, the more kind of shallow water it looks. A little bit more light getting through and scattering in there. You can see there, a little bit of a change. Just gives it an interesting color variation, a little bit of tonality. So you can play around with that, dark blue, green sort of tones. But that's pretty nice. Alright, so let's turn on the flip. Before we do that, let me just stop updating. In here, what I've got is a p-scale randomization, and this is just the same as what I did on the pop streams. So we talked a little bit about that a couple of streams ago, I think. So we're randomizing the particle ID, and then we're fitting that between 0.05 and 0.08 in this case. And then I've added this little multiplier on top. So first I did that. So let's check out what that looks like. So we'll turn on our flip and hit refresh. There we go. So probably the first thing that I would do when I'm coming up with my p-scale is I would just say, turn this off again. I would just say at p-scale equals, and I would just pick a number. I usually pick a very low number because the higher you go, you might, depending on what scale you have, you might accidentally make them super big and then it might crash, or it might just take ages to render. Like if you did 1, for example, you just have giant spheres everywhere. So you can see 001 is probably a little small. 0.1, if I set it to that, is probably going to be too big. But let's see. There you go. So, giant balls. But let's take it down to 0.08, which is what I arrived at in my randomness. So what that looks like. Even that is pretty big. Let's take it down to 0.5. And I'm scaling that up as well. It's surprising. Maybe this maybe this isn't right. Maybe I do need to change it. So that still feels, too big. Let's run it through and just see what it looks like overall. It's feeling kind of nice and foamy, I guess, but the fact that I can see those spheres is just, it is just way too big. This simulation as well actually is lower resolution than the previous one that I was working with, so that's probably why these values don't work now. Maybe? I don't know. Not sure. Oh yeah, because this is actually a times equals, I just realized. So this does have a p-scale value on it coming out of flip. Let's have a look at what that is. Stop that. Click on there, geometry spreadsheet. Let's check out that p-scale. 0.06. So what I was actually doing was multiplying 0.06 by 0.05, and that would have given me a very small value. So yeah, there you go. not just setting it, but multiplying it down. But I would still do this step where I try and arrive at a number that gives me a decent scale. So let's try 0.01. That might work a little better. Oh, move my view flag. That's why I'm setting it to white again, so it doesn't look like that. There you go. So 0.01 actually looks pretty good. Yeah, it's nice and small. We're probably going to get some of that detail back if I go to my out and up my pixel samples. You'll see if I go to 3, I should be able to see a lot more of those streams. You see how I get that back? This just might be really sparse in the render, so we're not going to be able to do anything about that. But a lot of these, you can see all that detail is kind of coming back in that area. Same deal down here, all that stuff sort of smooths out. But a lot of that is just render noise that we're seeing. But it's really slow, so I'm going to take it back down. Maybe I'll go 2. Let's see. That's a little better. I don't have any limits here as well, and I've got reflective surfaces, so let's put a reflect and refract limit of 2. That should help speed things up a little bit. A little bit faster. So look down here. Alright. So there we go. And the stuff on the water is looking a little better at higher pixel samples as well. Less kind of dotty. So that's pretty good. We could potentially go lower than that. So yeah, we could potentially take this down to 0.08 maybe, or 5. Let's try 5 first of all. See what that looks like. Nice and fine. So that could be good. But I think, you know, what is the best solution here is to randomize it so that we get variation. But that's looking quite nice and fine. So let's take our 0, 0, 5, and instead of doing times equals, I'm just going to do equals. I'm going to go between 0, 0, 5 and 0, 0, 8. And then we'll get some variation across. So you can see it's getting a little bit larger overall. But variation is always good. And we could go a little larger, go 0.01. Not all of those points are going to get that 0.01 value, but some of them will, and it will just help thicken it up a little bit overall. So you play with those, and then if you really wanted to just at the end go, well, actually, I need it to be a little bit thicker, I would just add something like that in. Instead of going in and changing these all the time, just add a little scale multiplier on there and go times 2 or times 1.1 or times 1.2, and then it will just overall thicken that stuff up. But we don't really need this now, because I think that looks pretty good. How's our render going? I think it might have finished our background render. I think I might have closed it. Let's see, Mantra rendering. Where is it? Render scheduler. Yes, finished. 100% on the mist. So we can go and check out that next. So that's looking pretty good. So it's a lot better than what we had previously with this one. You can see the flip. This is the flip. There's really sparse amount of points, and we're not getting a ton of detail. So that's looking loads better. I'm much happier with how that's looking compared to where it was. And this is just the flip. So we've got all the other components to go on as well. So let's have a look. I think that's looking pretty cool. Now, let's have a look. We've got flip streams. So these should have similar kind of settings. The flip streams, if you remember, I'm also randomizing the individual streams based on that stream ID that we created. You can go back and have a look at that. So you can see just turning it on gets picked up now, and there's additional stuff being added there. There's one there. So it's kind of hard to, oh, there we go. It's kind of hard to see them, but it's just an additional layer, which is going to help, you know, fill in the gaps and look nice. And obviously you can make them bigger or different color or different rendering, you know, render them as a different layer so you can composite them differently. Hey, Bernardo GD, how much RAM do you have? I have 128 gig. Some of you that have been watching the streams for a while will remember when I got it. It was very exciting. But yeah, I haven't always had it. I think previously I had 64 or 32. I can't remember what I was at previously, but yeah, it's definitely made a big difference having 128 gig. As you can see, I'm only using half of it at the moment, but the ceiling of, you know, where I can push things has just been dramatically lifted. You don't necessarily need 128 gig to do this. I mean, you certainly don't. But it helps, you know, it allows me to push it to a next level of quality and just allows me to do more with my machine as well. You know, prior to getting that, I had to be very careful about, you know, what I had open. I couldn't have multiple instances of Houdini open. So it certainly makes a big difference. But these effects are still achievable on half of that. 32 even, you know, you would be able to do it. You would just have to be really clever about how you set it up. You might have to be mindful of how many points you end up with. This flip sim, I think, has about 8 million or 6 million at this point. So yeah, you know, you can definitely do it with less. You just have to be careful with how you set things up. But yeah, I highly recommend it. I know it's expensive, but yeah, man, it just has made things a lot easier. My graphics card, yeah, it's a RTX 2070 Super. It's nothing special. At the moment, I'm doing nothing that is being utilized by the graphics card. The graphics card is not being used to do this rendering. It's not being used to do the flip simulation. It's not being used to do the pops. All the graphics card is really being used for at the moment is to display my viewport. So yeah, I mean, there's probably doing some other things, but yeah, a lot of things in Houdini aren't really GPU supported. So graphics card for me is kind of one of those things that, yes, it's good to have a better graphics card. It's always good to have better whatever. But for a lot of the things that I do, I don't get a lot of benefit out of it. If I was doing this in Redshift, for example, then yeah, I would get a good benefit out of doing it. But because I'm doing it in Mantra, it's all CPU based. So yeah, I just picked the kind of best performing graphics card price to performance ratio that I could find, or it wasn't even the best. I picked like the second one down. Yeah, you don't always need top of the line graphics card for a lot of stuff in Houdini. Again, it certainly helps. But yeah, 2070 Super, it's okay. It's a little bit slow sometimes with Redshift, but yeah, it's pretty good. My CPUs are just i7s, so they're not even top of the line processors, but they're pretty fast. I think it says 3.6 here, but you can see they're running at about 4.5. Yeah, how much RAM do you have? Oh, 16. Sorry, I had to move something out of the way to see that. Um, yeah, look, I did a lot of stuff on a laptop, you know, with 16 gig of RAM, and you will hit limitations, but you can do stuff. You can do some good stuff. It just, you have to be kind of you just have to be a bit more careful about, you know, about how you set things up, and yeah, the sort of stuff that you know that you're building. But there are lots of ways to kind of get around some of those limitations. I'm just looking for a project that I did. Let's see if I can. This might not play back for you very well, but this project I did ages ago. But I did this on my laptop with 16 gig of RAM, and I had to be very careful. You know, the explosions I would have liked to have been better, more detailed. Um, but I had to be very careful about how I set this up and how I simulated these. But you know, this is an example of something with a lot going on and pretty high res simulations that you know I could achieve on a 16 gig laptop just by managing, you know, managing my workflow and keeping things as efficient as possible. The explosions were certainly the hardest part of that. I had to. What did I have to do? I had to simulate them as 3 separate ones for a start. There's a bunch of different simulations. I had to split them up, and I think the main one was the one that took the longest. And I had to. I think I've talked about this in the past. I had to turn off. If I go and have a look. I had to go and have a look at the .NET, turn off the cache. So turn off cache simulation, and then write to disk. And when you do that, I'm sure I've talked about this a lot, but when you do that, it doesn't cache the whole simulation to memory. It will just cache a single frame and then chuck it and do the next frame. And that allows you to push, you know, a laptop with 16 gig or a computer, whatever, much further than you could otherwise. So that allowed me to push that simulation much higher than I could. Before I did that, it was just crashing. So, yeah. Anyway, where was I? Let's have a look at the... so we added the flip streams. We've added the flip. We could add the particle streams on as well. Let's turn that on. So that should give us the super fine kind of component. There they are there. They're looking a little thick now compared to the flip. So let's go and... we've got an equals and a multiply here. So that's setting this, the stream ID, so the randomization per stream. And then this is the randomization per particle. So let's take... It's a little bit kind of complicated to figure out, but let's take the 0.7 and 0.3. Or actually, we'll do that now that I've done it. But I could have just added a third at p-scale times equals 0.5, let's say, to halve all those values. But we should see that come down. There we go, it's a little bit thinner. So they don't actually need to be super thick, they're just a kind of supporting thing now. Because our flip is looking a lot better than what we had previously. That's now more of a supporting layer. So it could, you know, it could blend into the background because it's not as, you know, it's not as nice as the flip simulation. Doesn't have a lot of that fluid detail because it's just a simple pop sim. Yeah, we can blend it into the background a little more and just make it a very subtle supporting element. So there we go. It's looking pretty cool. Yeah, there's a lot of foam detail. Obviously, it'd be nice to see this in motion, but it's going to take a little while to render. But let's have a look at our new pyrosim. So I'll have a look in here first, check it out. I'll just hit save while we're at it, just in case. And so this is our new pyrosim. Let's have a look. So the disturbance is kicking it up a little bit. Maybe the disturbance, you know, I should have turned down a little bit. But you can see now it's not sort of squirting out as much as it was before. So you can plug it through the transform. You can see it's a bit more of a just falling effect, but there is quite a bit of disturbance on the top, and I think that's probably not going to look great. So I probably should have adjusted that, so that it maybe didn't affect this top section. We should probably look at how we could do something like that. But let's render it and see what it looks like. So come out. What frame were we on? 188. Let's go back to 188. And we'll turn on our render mist. So our render mist has the mist volume, which is this material builder that I made. So density being multiplied by a constant to raise the density into a pyro shader core. Oh, interesting. I have I have that on my list actually of something to look at. One of my students was interested in doing that. Daredevil credits, flip reveal effect. All those water particles. Yeah, so I did start setting that one up. It's very detailed, that effect, the Daredevil intro credits. So it does require quite a high resolution of points. But I have some interesting ideas about that effect. So yeah, we'll have a look at that at some point. Probably won't do flip again, because some people are desperate to see some explosions. Issa, how you going? In your opinion, if you spend 1 hour per day learning Houdini, how far? 1 hour per day. I think it would take you a little while. I mean, it depends how long you have. 1 hour per day over 10 years, you might get quite good. But I find 1 hour is not enough to really get stuck into Houdini. Like, at the end of that hour, you may just be like, oh, I'm just getting started. I don't know. I mean, if you only had 1 hour, then yeah, you'll get there eventually. But you really do need to commit a lot of time to Houdini. It does take a lot of practice, and it does take a lot of time invested in learning. I think ideally, you would want to spend more time on it than that. It depends how long you want to give yourself. If you don't have, that's right. Yeah, I mean, yeah, like if there are people on the chat who have been learning Houdini, let's have an opinion about how long you spend and how far you've gotten with it so far. I think yeah, it does take a long time. Not just Houdini, just 3D and VFX in general. It takes a lot of time investment. Hey John, how's it going? Thanks. Yeah, I think it just does take a long time to learn these skills, and a lot of practice. I mean, it takes a lifetime of practice, really. You never 24 hours per day. Yeah, that's right. I mean, look, when I was learning effects, it wasn't in Houdini, it was in 3D Studio Max, but I spent an entire year basically, living and breathing 3D, and I just threw myself at it. And at the end of that, I was able to get a job. It wasn't my dream job, but it was a job, and then from there, things happened. But yeah, I really threw myself into it, and the same when I learnt Houdini. Really, I took about maybe 5 or 6 months off work, and upskilled, and I pretty much worked at like a job, where I was 9 till 5, just working on Houdini, and then into the night as well. So yeah, I think if you really want to see results, and you want to see results quickly, like within a year or years rather than a decade, then you really do need to put a lot more time into it. It just depends what what you want to get out of it. Drinking water or beer, that's right. don't forget to take breaks. It's important to take breaks for sure. But yeah, look, you know, it does take time. It really does take practice. I think one of the important things with learning Houdini and with learning anything is to spend the time practicing on your own, away from tutorials. Tutorials will only get you so far. They'll get you to the point where you know, you can create some things in Houdini and you have an idea of how things go together, but until you actually try to do this stuff by yourself, you know, you'll constantly be kind of tied to the tutorials because you rely on them for knowing which nodes to connect to, you know, the subsequent nodes. This is why I don't really, you know, do those types of tutorials. I focus more on kind of the process and the ideas, and less on the do this, you know, and you get this result, because it doesn't help you, you know, it doesn't help you learn. And I know that from my own learning is that, you know, when I follow a tutorial, when I was following tutorials, I would just, you know, I would just follow the tutorial and I get to the end and go, cool, I made this thing, but I have no idea really how I arrived at this result or what all those things that I did do or how I could use them for my own work. And if you spend a lot of time doing tutorials, you will eventually it will sink in, and, you know, you can, you know, you can kind of transform it eventually if you do a lot of tutorials and don't take it in or think about what's going on. Eventually it will just kind of naturally, you will kind of know what to do. But yeah, I think it's better to just practice without the tutorials and just try, which is why I teach the way that I do. And yeah, thanks. I mean, hopefully it's you know, helpful seeing how I approach solving problems. And that's part of the reason why I just, you know, I don't plan this stuff and I just let you guys see all the mistakes and things that I make and the problems that I hit, because it's a big part of VFX and working in Houdini in general is just problem solving and trying to solve these things that you created these problems, and you just kind of have to create these things. Yeah, John, you know what it's about. So yeah. Anyway, you know, if you want to learn it, then just, you know, try and give yourself as much time as you can put into it. But if 1 hour a day is all you've got, then it's better than nothing. All right, enough jibber jabber. Render mist. I'm going to turn that on and hit render, and let's see what it looks like. Coffee time. Alright. It takes a little while to calculate at the start, and it's mainly because of the displacement. That's why it takes a little while to render it when I hit render every time. Let's have a look. Hopefully we'll get less kind of stuff in the air and more just sort of more falling down. But I suspect that it's still going to be a bit too active because of that disturbance. So we might want to create a mask for the disturbance. Let's see. It's hard to know without rendering it, but because I can see a lot of sort of stuff above the ship, I feel like it's probably still going to be a little bit too busy. Like if we have a look at that that render that I did, we're not going to have the squirting out so much anymore, so it's not going to look like steam being pumped out, which is good. But it may still just feel a little bit too sort of busy, and that's not really what we want. We want it to be sort of more of a mist being dragged up. Yeah, that's right, John. It's the making something for yourself. That's what helps cement the knowledge. You know, you do a lot of tutorials and you do a lot of learning and people teach you things, but only when you really try to apply that for yourself will it click in the way that makes sense to you. You know, like someone can tell you something and be like, that's the way to do it. But until you try to do it, your brain works in a completely different way to anyone else's. So until you try to do it and try to learn it and make it fit into your brain the way that it works, that is the point that that something clicks and you go, oh, I see, I understand now. Sometimes that might just be someone else teaching you the exact same thing, but explaining it in a different way. You know, that's another kind of thing. Is like learn from different sources. If something doesn't make sense from one person or one tutorial, go and find a different tutorial where they talk about it in a different way, or maybe they simplify it, or there are lots of ways to explain things that some people use. You know, different analogies that might make more sense to you, or just speak in a different way that's more easy to understand. So yeah, learn from all sorts of different sources as well. All right, so I dropped the res for the mist, and it is looking a little bit low resolution. I still think it's going to be a bit active, but let's just go with that. I'll work on it. Yeah, well, that's the interesting thing about Houdini as well, is that there are so many interpretations, and it's kind of open to different ways of working as well. Like the way that I do this will be different to the next person, and depending on how you've learned or not learned, or the things that you know how to do will influence your choices of how you do something. So yeah, I think a lot of the way that I create things is influenced by how I learnt to create things originally, and how I just make up processes, because I never really did courses or anything like that. I just sort of make up a lot of this stuff. So that influences the way that I kind of think about things. And coming from doing this 10, 15 years ago as well, I'm always thinking about how can I save resources, or how can I get this done quicker, or how can I do this without killing my computer, because back then we really had to make those decisions, because it just wouldn't get done, or you wouldn't be able to do it. So I have a lot of that as well, just my experience that influences the way that I create things. And that will be the same for everyone. Personal experience, professional experience, whatever, it all influences how you come to create things. Alright, so yeah, the mist, it's kind of looking alright. The water, the more I look at this, the water does feel very white, so we could experiment with a few things with that. Let's have a look at the scene view. And one thing that we could do is actually take our render flip geometry container here. Yes, absolutely. Absolutely, John. Render flip. I'm going to call this one render flip mesh. And I'm actually going to surface this one. So let's have a look. We have, I can't remember what, I think we did 005 on this one. Let's check it out. The voxel size is 0.1, which means that the particle separation is half of that. So we can go inside here just to double check. Should be 0.05. There we go. All right. Let's go back. Render flip mesh. Put down a particle fluid surface. Or actually, I'll put it down, but I'm not going to use that. I'm going to use something different. So put that down, set the particle separation to 0.5, and see what we get. It's probably going to be quite slow. It's quite high density of points. The RAM's okay. Yeah, it's pretty gross. Now, yeah, particle fluid surface, I don't love it. Sometimes it's okay, but for this really detailed stuff, I'm going to use VDB from particles. And then I can specify and control this a little better. So what am I going to do? I'll take my attribute wrangle. I'll just create a different one over here. and I won't do the randomization, but I'll do p scale equals 0.05, and then feed that in there. Minimum radius, set it to 0, and then we've got a voxel size here, which is our resolution. So let's set that to 0.01 maybe. 44 million voxels. That's not too bad. Let's do a VDB convert VDB, and just convert that to polygons, see what that looks like. It's going to be pretty noisy. But you can see, like, I get a lot of really fine details out of it. So I can come in here and up my p scale. Let's go 0.01. See what that looks like. We also have a lot of stuff below the water surface that we don't need, so I might cull that as well. There we go. So you can see now we're getting really nice fine meshing, and all this stuff below the surface doesn't need to be there. So in my wrangle here, I'm just going to add down here, if at p.y is less than, let's say, negative 0.5. I don't want it, you know, because this is the water surface, so I want it to sort of start maybe around here. Less than negative 0.5, remove point. So remove point, 0 for the first input, and then at pt_num for all points that are below that value. See what happens. Hopefully this will all disappear. Maybe not. Oh, there we go. Yes. So you can see there. It's just getting rid of that. You could probably do a clip node or something like that as well, but yeah, this just makes it nice and easy. I can adjust that, and you can see I can probably maybe do that 0.03. That will just mean that our volume that we're creating is much smaller as well, so it will be a lot faster and a lot less voxels as well. Probably might be able to increase this a little bit. Might not need it to be as high. Let's try increasing our particle scale a little bit. Yay, Vex, that's right. Caught me in a rare moment of using Vex. So you can see as we thicken that up, we get more of that coverage down here as well, all this stuff. Okay, let's have a look. There we go. That's not too bad. So what we could also do is is do a VDB smooth. Smooth SDF has a few more options than the other VDB smooth. So you have VDB smooth and VDB smooth SDF. And you can see they have different operations. So this one will work on volumes, like fog volumes as well. But this one only works on SDF volumes, which this is. So you can see it's grey, it's a surface field, it's a distance VDB. That is an SDF, a signed distance field. So the VDB smooth SDF will work on that. And it has some better options. So this only has mean, Gaussian, and median, which are very aggressive types of smoothing or blurs. No VOPs for you, that's right. I love VOPs, VOPs are great. VOPs are, you know, I know you're joking, but VOPs are how I got into a lot of the more complex ideas in, you know, Houdini. Start with VOPs and then go from there. So Laplacian flow and mean curvature flow actually respect the shape of the volume, whereas mean and Gaussian and median just do an overall blur. But Laplacian and mean curvature will actually respect the details that are there and try to preserve them. Still, you don't want to go crazy with the blur, but you will see that it will smooth, but without completely obliterating all of the details. Whereas if I change this to Gaussian or Gaussian, however you want to say it, you will see that, well, it just gets rid of all of those details. And it keeps the really large clumps together, but it gets rid of mostly everything. So these two, mean curvature and Laplacian, are really good for fluid smoothing and, you know, high detail stuff. Laplacian, I think, is probably my favorite. So there we go. add a little smooth. I think we probably need more resolution. Another thing you can do is actually make the piece scale slightly higher and then smooth to pull it back down a little bit. Higher resolution will give us a few more of those points. Alright, so there's a ton of stuff going on there, but that looks looking pretty cool. Let's have a look with the ship. So this is over the top of our flip now. We don't necessarily need the flip in there as well. This is just going to give a different look. Let's have a look. Camera 1. Flip mesh. Now this has the pop streams material, but I'm going to... We could do the water material. What I might do is duplicate that, and I'll call this one flip water. And this one will probably try transparency, so I can drag this on here like that. That should have applied it there. Flip water. Alright, let's try it out. We hit save. Let's take a snapshot of that, and let me turn off these things so we're just focusing on the flip mesh. Render. Have a sip of coffee. And when I was learning 3D, I used to drink so much coffee. It was instant coffee, so it wasn't super strong, but boy, a lot of cups of coffee a day kept me going. Probably wasn't very good for me. There you go, it's creating the water displacement. You can always turn the displacement off while you're testing as well, and that will help your renders go faster. We could also turn off the water, just when we're focusing on the ship. Okay, let's see what we got. Oh, actually, this has that displacement on it. I just realized, so it's gonna have displacement, which is probably why it was taking a little bit longer. Let's just turn that off. We don't want that. And in fact, let's turn it off on our water as well, and then it should hopefully render a little bit faster. There we go, start it up a little bit faster. Let's see. Oh, it looks like our pyro is still on as well. I'm going to turn that off. There we go, it's a bit faster. So you can see it there. It's got the same material that this does on it, so it looks pretty bad. Let's go material, flip water. What have we got? Reflectivity. Ooh, we can see the sky now, nice. Let's turn on transparency, set to 1. So it's going to be like a water now. Also, because this is sitting on the surface of the ship, it's going to be casting shadows onto the ship, which we don't really want from water, so we usually want to turn on fake caustics. And it's a little bit hard to tell, but it will have sort of lightened this a little bit. It will no longer be casting a solid black shadow underneath the water, and it will just help make it a little bit brighter. Overall, it's probably a little thick, that water, I reckon. As I said, it's a different look, but just trying to get, you know, just playing around with some different ideas. Now, it doesn't have to be perfectly transparent like this either. It could be sort of, you know, if we gave it some roughness. This is the thing I don't like about the principled shader, is that the roughness is for both reflection and transparency. You don't have a separate roughness control for transparency. So actually, I'm going to part ways with the principled shader now and go to classic shader. This is the one that was the shader before the principled shader came along. And let's apply that. So I'm going to call this Flip Water Classic. Coke Classic. Does anyone remember that? Let's put that on there. And now, the reason I like the classic shader, and I use it a lot for liquids, is because of the specific controls that I have per channel. So reflections, separate roughness; refraction, separate roughness; separate IORs, and just when you're doing color as well in refraction, this works a lot better. gives a lot more sort of a direct color change. Okay, so there we go. We've got a diffuse shader coming through on our classic shader. Let's turn on refractions first and turn off diffuse. That should just give us a clear refraction. Again, go to the opacity tab, turn off faux caustics, or turn on faux caustics. See, it just lifts it a little bit. We have IOR here, so you could make it like 1.1. It'll be very sort of transparent. I think water is around 1.3 IOR, but 1.1 will be like a pane of glass basically. We'll leave it. Let's leave it at 1.3. I want to go to refraction and make this sort of a bit rough. 0.5, and that will make it lighter. It will scatter more light through because it's rough, and it will make it kind of white, a bit more foamy looking. We could also add a tiny bit of emission. That'll make it probably bright white, so we can turn that. Let's give that like a very small amount of emission. Too small. That'll give it that lift, that little sort of brightness lift to make it feel a bit more foamy as well. Maybe the roughness is a bit much. So you can sort of play with that. You don't necessarily need emission. I mean, this was meant to be a kind of different sort of effect anyway, but you can see it gives it that lift as though light is sort of scattering all the way through it, even in the shadows. But it can tend to grey it out a little bit, just looks a bit weird sometimes, so you have to be careful with that. Turn it off, let's see. Yeah, I don't know. You can also not have full intensity on the refraction, so you could have like some diffuse here, set that to white. And it's weird that it's coming through with the refraction on. I thought it wouldn't do that. Base color. Yeah, odd. I thought it didn't do that when you had base color on, when you had an intensity of 1, but maybe it does. Maybe it does. Let's turn reflection. We've got reflections on. Let me turn that off. Let's see what that looks like without it. Yeah, weird. Oh, intensity. I guess if we turn that down to 0.1. Oh, there we go. So we can actually just control the amount of intensity of that diffuse. So we've got pure refraction going on, a little bit of diffuse there, giving a little bit of white just on the edges, which is kind of interesting. Oh, there we go. It's a bit of a lift. It's kind of like doing the emission as well, but diffuse will be subject to shadows, so it won't get too bright in the kind of shadowy areas. And then let's turn our reflections back on. Reflections by default have a 0.3 roughness, so we can turn that down. We could also give it a color if we wanted to. The refraction color is white by default, but you could give it like a slight tint, ever so slightly. You don't want to go like don't want to go crazy with it. It'll just look a bit weird. Although actually, that doesn't look too bad. It's kind of cool. Let's just make it a bit subtle. Yeah, you can see up here it just feels a bit strange. So I just want it to be a slight tint. You can see it in there, just that very subtle blue. Just helps transform it into something that's not just completely monochrome. Turn off the diffuse, let's see what that looks like. I think that's always the issue with a lot of CG stuff, is that all the defaults are, you know, black and white and monochrome. They don't have any color. Lights, you know, usually just white. So you add color to the shaders, but certain aspects just, they do feel very monochromatic and plain. So pyro sims especially, you know, they're usually just single colors. So anywhere where you can add a little bit of variation, color, you know, tonal differences, little sort of variations can really help. You could do that in the particles. You could transfer those colours from the particles just to give detail. This is possibly too much, but you know, it's good to experiment with colour. I like how it looks in some places and not others. So there's a very kind of different treatment of that flip simulation where it's more water rather than foam. Now, let's just see what happens if we do both of those. So we'll get our white particles back, although they're taking on a bit of that tint when they're underneath. But now we'll get a kind of combination of the watery effect because it's slightly more inflated. Because it's slightly more inflated, it will sort of show up in parts and not in other parts. So we'll get maybe an interesting mix. So that might be an interesting approach as well. It has made the white water a little bit blue, which is maybe a bit unfortunate. I think transmission tint, if I turn that off, let's see. Yeah, that's kind of reduced that amount of blue that's kind of that's being transmitted through the refraction onto anything that's below it. So it might still refract blue, but in those areas where it's going to transmit to other objects, it's not going to do that. So that's a little bit better. Hardy, can I talk about the Watership post on my Instagram? Yes, my Instagram of one post. Yeah, let me find it. I did that for just for fun really, but I thought it might be a good project. Let's see, where is it? It's called Storm in a Teacup. Bring it up. This one. Is this the one you mean? I think this is the only thing I have on my Instagram. Thanks. This was rendered in Redshift, and it's a flip sim without white water. So, I mean, even though it looks like it's got white water, the white water is all done in the shader. So basically there's a flip simulation, and I'm outputting the vorticity attribute. You could also do this with speed. You could do this with the V attribute as well. And I'm changing the shader based on that attribute. So when the water is highly vorticide, I don't know if that's a word, but when that vorticity attribute is higher, it changes the color of the water and some of the rendering parameters to white from green. And when the vorticity is low, then it goes back to being that more transparent kind of ocean shape. Now, in terms of the simulation, there's also an RBD simulation which is driving the boat, and a vellum simulation for the sails. The vellum is actually done as a post simulation, so the boat is solved with the water at the same time, and that was incredibly challenging to get the boat to not tip over, because if you try this with an object, it will just either sink or it will flip because of the turbulence. So I had to come up with a way of kind of making the boat always right itself, so that it never, and it looks a little bit kind of constrained, but it's sort of it helps it not to flip over or sink, basically. How much time do you mean? How long did it take me to create it, or how long did it take to simulate? It took me probably maybe a week or two of working on it, I think. The simulation actually is pretty quick. It's not a super high res simulation. I think I was working on it for about 2 weeks on and off, not full time, but it actually came together surprisingly quickly. And then rendering in Mantra was incredibly slow, so I did switch to doing it in Redshift, which I think worked pretty well. The Mantra renders were, overnight renders, and even then I think they still weren't done, but in Redshift it was like maybe 1 hour or 20 minutes or something for the whole sequence. The simulation, I think, is maybe about an hour to 2 hours for the flip sim. That was by far the most challenging part. Was the flip sim is easy. It's basically just a pop wind with turbulence. Or not a pop wind, a pop force. Just with turbulence. Just creating that churn. But the ship was just the most challenging thing, and that's what I spent a lot of the time on. But yeah, I didn't spend loads of time on it, but well, there is wind in there, John, for the vellum, but that is a static simulation. So basically what I did for the vellum was I froze the boat on the first frame, and I ran the vellum sim with a wind, just with noise to simulate flapping, and then I attached those sails to the animated boat, so it just sort of it all looks like it's part of the same simulation, but it's the wind effect has been faked on the sails. The Mantra renders look exactly the same. Basically, I tried to match. I because I'm more comfortable with Mantra, I set it up in Mantra to begin with, and then I had to sort of match that in Redshift, which was challenging. But the Mantra renders would look just the same. Just the render time was incredibly slow. I don't know if I have. Any of the Mantra renders here. I don't think I do. What is this? If you see, like, I took some stills of it, like pushing the camera in as well. So, you can kind of do that sort of stuff where you zoom into it, and that's pretty cool as well. I want to do more sort of things like this with the boat scenario, maybe a higher resolution, larger scale, but you can get some really interesting shots if you punch into it. So yeah, it was a fun project to work on. And then we go back to this, which looks a little bit sad in comparison. I don't know what it is. I think maybe it's the flip water on top of the white has sort of taken some of the luminosity out of it. The boat is incredibly fun to simulate and play with, but it was very frustrating to make it stay upright. I ended up using like pop look at and a few like custom vex things to stop it from sinking, essentially. Like if we have a look at it again, I have this basically a pop wrangle which is measuring where the boat is in space in Y, and if it goes too high I pull it down, and if it goes too low I push it up, so it keeps this kind of constant equilibrium of the center. And I think I added one for front and back as well, because one thing that would happen was the boat would get pushed to the side and then get stuck against there's a sphere as a collision. It would get stuck against the sides. So I have all these forces trying to pull the boat back to the center, which, is... Yeah, I guess, you just have to do these things when you're looking for a very specific result. I probably could turn some of them down so it's a bit more free to rotate, but I find, like, if it does get a little bit too much rotation on it, it will flip over and sink. Might be fun for the bloopers reel. Alright, so yeah, I don't know, the flip mesh, it's an interesting thing to try, but you can see it it does suck the luminosity out of my foam. But it's kind of maybe an either or scenario, like you could have both, or you could, or perhaps I could just crank the pop streams brightness. Don't know if I have emission on here, perhaps I could add a little bit of that. Set that to white, give myself a little bit of emission intensity, and that will probably brighten those up again. There you go. Alright, and let's turn on our flip streams, our particles. Oh, mist particles. I can't remember if I covered that last time. Yeah, that's right. Well, I think with RBDs and flip, you have density as well. So there's like a weight. There's a point where the boat will just want to sink based on its density compared to the relative density of the flip. So that's another thing that you're fighting with. But yeah, the flip will just tend to want to push it down. So let's have a look with all this stuff on there. Maybe I'll take the tint off the flip refraction. Or just turn it way down. So we've got all those things on. And then, yeah, I can't remember if I covered this. I probably did. But this is the particles that are kind of inside the mist. I'll need to redo these. But they will sort of be little points that go inside the pyro simulation, just to give it that sort of feeling of having, you know, little drops of water inside. So you'll see that'll add some sort of particles to the air. Maybe a little bit, not sure where they are exactly. There's a few little particles coming in there. Alright, and let's go and turn on our displacement as well, because that really does help. Texture displacement. There we go. There's a link, John, to the model in the description of the video. It's from CG Trader. I can't remember the artist's name right now, but it was just one that we bought for another project, and yeah, you know, I just have it sitting there, so I thought, oh, it'd be cool for this. There's lots of detail. It's really nice model. So check it out. It's not particularly expensive. Yeah. So I'm testing this all together, but you know, as I have demonstrated in the past, or I might have talked about, I will be rendering this all separately. So once I've kind of decided that, you know, this is looking fine, you know, looking okay, then I'm going to go and set up my individual elements. So you can see I've got, you know, some of these things set up already. But let's create, so I might take my surfacing test, the thing I've been rendering with, and let's do flip points v1, and we're going to, instead of doing wildcards, we're just going to choose render flip like that, and under forced matte I'm going to put render ship and render water, so that what I should get is just the flip. And then I'm going to take all this into Nuke and composite it back together. We've got 15 minutes, we probably might be able to do it. Layer up one frame. So there you go, you can see just the flip points. Let me open up Nuke. Yeah, crack that open in the background. So there we go, that's looking pretty cool. Just let that finish off. And then I'm going to duplicate that, and let's create our flip. What have we got? We've got flip streams, we've also got particles, so I'll do flip streams. V1. I'm just going to save these manually, but you know, really I would be doing render to disk. So I'll just save these to some location. one's called flip points v1. I'm going to save it as an EXR. So just like that, flip points v1 $FXR, accept. And just hit save, it's fine. And then I'm going to do that with all these layers. So let's just hit render on that one. And you could combine, you know, you could potentially combine flip points, flip streams, and the particle streams into a single pass. But I kind of want the ability to maybe mess with them. So that pass could certainly do with up-resing, I think. But we'll do the same thing. We'll just save that. Call this one flip streams. Oops, streams points. Save. And this one is going to be particle streams points. Render layer names are probably not the best. Alright, let's see what that looks like. And then we already have one for mist set up here, so I'll check that out. There we go, there's particle streams. I'll just call that one pop streams. And let's check out the mist one, see what that looks like. Alright, so I've got nuke here, and I'm just going to go and navigate to those locations. So here's my spaceships rising, just putting them in this test. So I can just grab these files and drag them in. And there I've got now my renders. That. And let's check that one out. So that gave me nothing. Render mist. Let's just jump out, have a look at that. Oh, it's not turned on, and shouldn't matter. I should probably put that in the forced objects, and then it won't matter whether it's on or off. But that now should render. Same thing for the mist particles. We could put that in the forced slot. There we go. So there's our crazy noisy mist. Let's call this one mist. And let's do mist particles. Let's see what's in those. Don't actually know what those are looking like at the moment, but they're probably not going to match this mist because I didn't re-simulate those, but might get something. Yeah, it's something. We'll get it in there. We can always update the pass. Sometimes it's good just to block out all of your, all of your passes first, and then come back. So render water. If I just do that like that, I'm just going to get the water without anything showing up in the reflection of the water as well. And that's going to look a bit weird when we combine everything. So I might just take those pixel samples down to 1. Let's try that again. First time we're seeing nuke in a stream. Oh, I have done nuke. I did nuke back in. If you go back and have a look at my first streams, the Kong streams that I did, the King Kong shot, the very first stream series that I did nuke in that. And I think I may have done it in some other ones as well, but I haven't done it for a while. Switch computers and the volume is so different. Yeah, I would assume that would probably just be the system volume, John. Because I didn't touch anything, although who knows? I'm having weird audio issues today. So, water. So I'll save that one out so that we can talk about what I was just mentioning. And let's create another mantra node here for the ship. And we'll render that one. need to put the ship in there, objects, so render ship. And this one, we're going to need the water as the matte, because for a lot of the shot, the ship is under the water, so we don't want it to be visible. We want the water to cut out the ship where it should be below. But there you can see the ship by itself. And you can see it renders quite quick when the water's not in there. Well, let's put the water in as the matte object. At this point, only a little bit of it is probably below the water. I think just these kind of wing sections. Maybe some of these little bits. Let's have a look. There you go, it's cut out some of that stuff that is below the water now. Alright, let's save that. So we'll call that one ship. And save. Okay, let's go back to Nuke and we'll drag in these new ones. I'll just drag them all in again. Drag them all in. Okay. So here's our water. That's the background. And then our ship goes on top of that. So we would, I just hit M to merge. So there's my ship over the water. And you can see it looks a bit weird because there's no shadow or reflection of the ship on the water. These parts here should really be in shadow. So it makes the ship look like it's just slapped on top and doesn't integrate well with the water. So I want to go back to my water. Back here. And we're going to add the ship, not to the matte slot, but to the phantom slot. And in fact, I'm going to add everything that I've got rendering here. So render particles, mist, mist particles, mist, flip streams, and flip in there. So there's without, and here it comes with everything in the phantom slot. Just going to calculate all those points. And there we go, a lot of shadow. So over here it should be the same. But you can see all that section that's under the ship is actually dark because it's in shadow. And it will be reflecting some of that stuff as well. So we'll see, yeah, it's kind of hard to tell, but it will be reflecting the particles and the mist and stuff like that. So you really want to do that when you're doing this layer-based technique. You don't want to have no phantom objects in your background layer, or maybe it's just a ground plane. So you definitely want to have shadows from whatever you've got going on top of it. Otherwise, it just looks like this, and it looks wrong. You know, you can tell that it doesn't really seem to be there, or maybe it's much higher off the surface than it should be. Yeah, that's kind of what it looks like, that the water is much further away. You know, if we put a maybe a defocus on the water so it looked blurry, then you know, maybe the ship is actually much further away than, you know, what it should be, so that it, you know, feels like it's flying in the air. But that's not what we want. We want it to be on the surface. So there you go. And it looks pretty cool. Looks like there's a nice shadow ship. Okay, so let's save this. Whoops, cancel. Save frame. We're going to save that as water. Accept. Save. Overwrite. Come back in here. Hit reload. Hey presto. Looks a lot better, doesn't it? So it's really important to get that right. And now it looks like those things haven't been rendered separately at all. But I have the ability to turn each of those layers off. Now, on top of this, we can put our other layers. So let's put, I think, our flip points first. So that's sort of the most dense layer. So I think I'll put that down first. Over. Ah, that's interesting. It looks like one of the resolutions is different here. This one is 1280 by 720, but these ones are, and maybe the ship too, but these ones are actually half res. So I'm going to put a reformat down So you can see when I merge those together, it doesn't fit, and you get this weird stretching on the edges. So I'm going to put a reformat down and reformat that to 1280 by 720. There you go. Now it fits properly. And you know, here is where I can put a grade down and I can actually play with the luminosity of that, take it back, add a tint if I wanted to. You know, I can mess with these layers, and you can see I'm able to affect just the layer because it's rendered separately. You know, if I was doing this on everything rendered together and I wanted to do that, I couldn't. You know, I could only have very limited range in what I could do because everything that I do affects everything else. So I could really just sort of control the brightness of the overall shot, try and crush it to create some sort of interest. But by having everything split out, it allows me to just focus on that element that I want to. So there's our flip points. Let's now merge in our, what else have we got here? We've got the flip streams. We're going to need to reformat these as well. There they are. So the goal is to try and just, you know, get everything back to what we had if we rendered it all together for starters, and then we can start playing with, you know, those things. So we've got flip streams. Oh, that's the pop streams. Then our mist and our mist particles. So I might put the mist on at the very end. The order of these probably isn't terribly important, but because they're all kind of just adding on top of each other. So there we go. Mist particles are very, very hard to see, but we could crank up them if we wanted to. We can make them brighter so that they just really pop. If you increase gain and decrease gamma, you get the effect of contrast. So you can see when I do that, I sort of can crush the effect to create some bright and darker parts. Yeah, that's right, John. I mean, this is why nuke is important, so that you can take a whole bunch of renders, or take, you know, one render, split it up, and then you get so much control for what you know, what you want to do with your effect. At any point, I can come in and go, well, actually, I want my ship to be super black, or I want it to be a little brighter. You know, you can do that. The water. Actually, I want my water to be a little bluer. And let's have a look at our flip. So you can see I just have so much control over every facet of this now that I don't have to endlessly tweak my shaders in Houdini. Now I've got this control in Nuke. And I also have the ability to go, you know what, I really do not like that. I'm going to put down a roto shape. You tab and type roto, or you can hit O. Gives you a roto. And I'm going to stick a multiply down. Multiply math. There's a couple of different multipliers when you type multiply. That's the it's the math version. And then I'm just going to draw a shape around that and plug it into the mask, the right hand little arrow there on my multiply. Set that to 0, and it's gone. It looks like I'm removing a little bit too much there. With an animated shot though, what I would have to do is actually move this and animate this mask with the ship as it's rising. So every time you change keyframe or change frame and then move this, it automatically animates. So I could just trace that shape if I wanted to just remove that line that I didn't like. I could just animate that along as the ship is rising up, and it will animate that mask for me. I don't want to do that because this isn't animating, but yeah. Whoops. Roto shapes are really, really great for just doing selective masking, removing certain elements rather than going back into 3D and removing it, which might be tricky. I can go and do that. Now the mist is a bit too kind of intense, so I'm just going to take that down. And you can kind of create your own mist as well by taking things like, you know, let's take our particles, maybe our flip points, or maybe the flip streams, or maybe a combination of them. If I take this element here, for example, and blur it, I could kind of create the effect of a sort of misty element over the top. Now I don't want to, what am I doing here? Oh, interview this below, there we go. All the way down here. So you can see, like, it needs a little bit of refinement, but I've got this kind of now just blurred, misty kind of look over that I can sit over the top, and I can control, you know, how much of that I want. But it just kind of sometimes helps with certain things. You may just want to merge that in right down the very end, so it's on top of everything else, as just like an extra little layer of mist. And you could take potentially all of the layers and merge them together. So we'll take all of these layers here. When you want to, like, see, there's no arrow for me to grab to plug into this merge now, but if I select the merge first and then the node that I want to connect and hit Y, it will hook it up for me. So I can merge all these things together. So do the same thing, click on that, click on that. You got to click on the merge first because it works on order of operation. Yeah, that's right. It gives it that kind of effect. I mean, that's probably too much, having everything in there like that. But just as an example, you know, it's something you can kind of play with. Maybe the flip points are too much. There we go. You just might want it to be a subtle thing, and maybe we plus it over, so it's an additive type effect. And it's just going to give that feeling of atmosphere in the air. And I really like doing things like that, because it just helps things sit in a little nicer. You can see, you know, well, I made my ship a bit dark maybe, but there's a lot of contrast between all these layers at the moment. But if we just knock them back a little bit by adding that kind of misty element, and maybe we brighten that up, you know, like that, and then just fade it down a little bit. It just sort of helps tie everything together and gives it that feeling of atmosphere that, you know, is otherwise lacking. Yeah, that's right. Doesn't need to be much. It can be really subtle, but it does help. So, you know, I probably overcranked a lot of this stuff just to illustrate a point, but that one I think is probably a little bright. And you can see here the mist. So probably what we should do is actually put the mist, unless we set it to plus instead of over. You see when I set it to plus, it knocks it right back. When I have it set to over, it actually occludes all the layers that are behind it, because the density is probably a little thick in that area. See, this is the alpha. So when I put it on over the top of everything else, it actually hides the things that were there before. So it makes it feel really dense. So you could change the layering so that you put it up here above the ship, but because it's a very fine mist, let's just set it to plus, and then it will just be an additive effect, so it won't actually occlude anything, it will just add the value to the image. And that works a lot better for things like mist and atmospherics. So yeah, you know, I've overcranked some of these, made them a lot brighter than probably they need to be, but I think that this way of working, and this is the standard way of working in VFX, if you get into film, this is the standard way of working because it is so flexible. It means that if I want to change one part of my render, I can, and sometimes I can just do it in Nuke rather than going back and re-rendering it, which we all know is incredibly slow. So, you know, if the director came in and went, oh, I want a little bit more green in that ocean, I can go, sure thing, buddy. give me 2 seconds, I'll give you another version. But, you know, if I had to re-render that, I'd be like, well, you know, I have to submit that to the farm and re-render it, and I'll maybe get that back to you in a few hours or maybe tomorrow, which sometimes is unacceptable. But you can see, like, I can play with the contrast to change the lighting, and this is only like the tip of the iceberg in terms of what you can do with comp. I have no render layers here, like I have no what are called AOVs or extra image planes, which would allow me to completely relight this scene or change just the reflection component of a shader in Wick. So that's, you know, where it can get even more powerful. But you know, there we go. It's looking okay. I think I want to definitely increase the resolution of the mist, so I'm going to do that and see what it looks like in motion. I'll render this out during the week, and we can come back and have a look at it next week and talk about any final sort of things that, you know, might help with this effect. You know, this is not meant to be a full-on flip explosion out of the water. It's meant to be a more subtle kind of thing. But yeah, you know, I think it's not looking too bad, and it gets better as it goes towards 240. But obviously, I didn't have that amount of frames in my simulation. So I'll do the full sim and see, you know, kind of what it looks like. This be done with a stand-in model and then applied as a mask. I don't know what you mean by that, John. Which? What do you mean? Yeah, so, you know, I think we're pretty close to finishing this off. I think next week we'll just do some... Oh, right. I mean, yes, you could take this effect and reuse it for many different things, yeah. And, you know, these approaches could be used in many different sorts of effects as well, and we can take a look at, as I go through things, you'll see me do similar things, and you'll be like, hey, you did that on the ship rising, but it'll be a completely different effect. Yeah, so I think we're pretty close. I'll render this out and we can have a look at it next week and talk about any changes, and then we'll move on to something else, maybe explosions. At some point too, I'll probably be talking about the next Kong project that we're going to be doing at CG Spectrum as well, so we might be doing some work on that during the streams. But yeah, I think this is all coming together. There's a few little changes, and there's probably some things that I would want to refine. But in terms of, you know, working on it for a couple of hours every week, it's getting there. It's coming together. So cool. Well, it's 10:12. I'm over time. Got on a roll there. Sorry for going over. I'm sure you guys don't mind. Thanks for joining me. No worries. Thanks, Hardik. Yeah, thanks for coming along, guys. Thanks for the questions and taking part in the conversation. It's always good when people are chatting and keeping me company. Yeah, I'll see you guys next week. We'll talk about finishing this off and have a look at a final render and do some more compositing stuff maybe. But yeah, please feel free to keep suggesting ideas for the streams, and if you have any questions, please feel free to ask in the comments, and I'll try and get back to you. Thanks, Audrey. Thanks, Michael. Thanks for coming. I'll see you guys soon. Bye, everybody.